Now let's take a look at session passing and session prepping. Right away, you should notice that we are in a PowerShell.exe context. That is not a safe context for post-exploitation. Even if what we're doing is relatively benign, we may be vulnerable to a point-in-time analysis that is looking for signs of a memory-injected DLL in this process context. We do not want to live here. So let's get out of this particular process. Let's right-click, Explore, Process List, and let's get a lay of the land and see what's happening on this target system. Here you can see that we are in PowerShell.exe, which is a child of a 64-bit PowerShell.exe, which is a child of Explorer.exe. Now we could inject into another process. In fact, that's what we're going to do. Let's go ahead and jump over to process 5392, the Java Update Scheduler, and let's inject our payload there. So we'll highlight that, press Inject, choose our listener, hit Choose, and if all goes well, we will get back a new beacon session that lives inside of Java Update Scheduler. And you'll note that it has the default 60-second sleep time. We will address that. But let's go ahead and clean up and get rid of this session. So we'll right-click, Session, Exit, and when Beacon acknowledges that it exits, you will see that the little monitor here will fade. And here you can see the same thing in the console. The exit command and Beacon acknowledging the exit. To get rid of this stale session, right-click, Session, Remove. It is now gone. All right, let's get rid of these tabs and let's change the sleep time here to 5 seconds, which I think is workable for this demo. And when it checks in, it will pull that task, and we are now beaconing back every 5 seconds. Great. Now let's take a look at passing a session to another Cobalt Strike server. Let's go right-click, Explore, Process List. And again, we're doing this to get a lay of the land. And you'll recall that I said we should do session prepping before we start launching processes. So that's what we're going to do now. And we have a couple interesting options here. We could session prep. We're living in Java Update Scheduler, right? Well, we could actually make our child processes run as Java Update Check. And that could be a pretty plausible reason to have child processes off of Java Update Scheduler. Or we could use this Internet Explorer instance and spawn child tabs as children of this process 1012. Let's start out with Internet Explorer and make it our parent process. So we'll do set as ppid for process 1012 here. And that is going to issue a ppid command to our beacon console. And now any programs that are run through this beacon session will have Internet Explorer as their parent. And we are going to use Internet Explorer 32-bit as a temporary process for 32-bit post-exploitation jobs. So let's do spawn 2, x86, and I think it's C program files, x86, Internet Explorer, iExplorer.exe. So now we've changed our spawn 2 value and our ppid, and now we're good to try to pass a session to another team server. Let's connect to that server. Cobalt Strike, new connection. Let's go to secure.losenolove.com, press connect. And here we are. We are now connected to secure.losenolove.com. If we go to Cobalt Strike listeners, you will see that we have our listener named EC2 Secure HTTP. And again, that is to be descriptive of which server the listener is tied to and how it's configured. Now let's come over to our other team server, right-click Spawn, and you'll notice that we can see the egress listeners for all of our team servers. That's what happens when you connect to multiple servers. So let's choose that Secure HTTP listener, hit Choose, and when our beacon checks in, you will see that it is downloading that payload. And let's jump over to the other server. And here you can see we have a beacon living in iExplore.exe PID 5064. Right-click, Explore, Process List. And when that populates, if we go all the way to the bottom here, you can see that we are a child of Internet Explorer. We look like a child tab. So that is an example of session passing and session prepping. Now let's take a look at a foreign listener, which is a way to pass a session to the Metasploit framework. Let's come over here to a terminal, and we will start up the Metasploit framework console. Give that a minute. And let's do use exploit multi-handler. And this is just a generic exploit to host a payload handler. And let's do Windows Meterpreter reverse HTTPS. Note that I am using a 32-bit payload. Cobalt Strike's foreign listeners expect they are passing a session to a 32-bit handler. Set lhost, set lport, and let's set exit on session to false so that we can keep passing sessions if we choose to do so. And let's do exploit-j to run this in the background. And there we go. We now have our reverse HTTP handler. Great. Let's come over to Cobalt Strike and let's not maximize this. Let's see what's going on in Metasploit. Now let's right-click, Spawn, and we need a foreign listener. Let's press Add. We'll do foreign HTTPS, and we will call it local meterp HTTPS. And let's give it our IP address because Metasploit is running on the same system. Hit Save, hit Choose, and when our beacon checks in, you can see we get Meterpreter session 1 opened, right? Now let's come over here. Let's sessions-i1 to interact with Meterpreter. Do a get PID. You can see Meterpreter is in process 6644. Come over to Cobalt Strike. Let's come over to our process browser, hit refresh, and there we go. We now have 6644 hosting our Internet Explorer tab for Meterpreter. And so that is a foreign listener.